download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about static electricity. Now before we get into static electricity and what it is, we first need to be fully aware of these two terms. So if electrical charges can easily move through a material, it is called an electrical conductor. Now if electrical charges cannot easily move through a material, it is called an electrical insulator, and we need to understand these terms before we move on. So an electrical conductor can transfer electricity through it, and an electrical insulator cannot. Okay, so a static charge is an electric charge which cannot move. Now static charges are usually found on electrical insulators where charge cannot flow freely through them. Okay, so a static charge is an electric charge which can't move. Now we've just said electrical insulators are where electrical charges cannot pass through and therefore they cannot easily move. So it would make sense therefore that a static charge, which is a charge that cannot move, would be found mostly on electrical insulators. Now they can be positive or they can be negative, and a static charge can build up on a conductor if it's isolated. In other words, if there's nowhere for the charge to go, but usually, as we just said there, they build up on insulators because electric charges cannot flow through insulators. Okay, so what happens is when a certain insulating materials are rubbed together, friction causes negatively charged electrons to be scraped off one. Okay, so for example here, we're going to draw a bit of metal rod. So this is metal, and here we're going to draw some cloth. Okay, that's a bit of cloth. Now when these are rubbed together, what happens is the friction between them causes electrons to be scraped off one of the materials. Okay, so in this case, let's say the electrons will be scraped off the cloth and therefore onto the metal. So the electrons, when they're rubbed together, it scrapes the electrons off the cloth and onto the metal. Now because this cloth has lost electrons, it's lost negative charge, this cloth is now more positively charged. Whereas because this metal has now gained electrons, it is now negatively charged. Okay, now this has a static charge which is positive, and this has a static charge which is negative. Now, it's important to understand that which way the electrons are transferred depends on the two materials involved, and you don't have to learn specific examples for this, but just be aware that electrons can move either way, and it depends on the materials that are involved. Now, both positive and negative electrostatic charges are only ever produced by the movement of electrons. So you don't get any movement of protons, obviously, that would not cause the positive or negative charge. It's always to do with the movement of electrons. If they gain electrons, so if they gain the electrons, they're going to become a negative static charge. Whereas if they lose the electrons, they will become a positive static charge. So the point really here that I'm trying to make is that both negative and positive static charges are caused by the movement of electrons, and a static charge in general is caused by the movement of electrons. And a static charge, remember, is an electric charge which cannot move. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now, a spark of charge will jump across the gap between a charged object and an earthed conductor if the potential difference is high enough. So let me explain in terms of a car, for example. So let's assume that this car is building up a static charge, a negative static charge. Okay, so it's building up that negative static charge. Now, if a person was to then come along, and this person is earthed, and what we mean by that is it's touching the earth. Okay, so it completes the circuit between the car and the earth when the person touches it. Now the earth is at 0 volts, and the more static charge this car gains, the bigger the difference, the bigger the potential difference in the volts between the car and the earth. Now, when this potential difference is large enough, these electrons can jump from the car to the earthed object, and remember what we say, an earthed object is something that's touching the earth. So here in this case it'll be through the human and then down towards the earth, and that feeling is that spark. So when you touch a car and you get a spark, or when you touch something and you feel that static shock, it's because the electrons are jumping from that object through you to the earth. And that is because of the potential difference, the difference in voltage between the charged object, which in this case is the car, and the earth. When that's large enough, the electrons can jump from the charged object through you down to the earth. And that experience is a spark. Now, electrons can also jump between a charged object and any earthed conductor that's nearby. Now, when two electrically charged objects are brought close together, they exert a force on one another, and this you'll learn in the next videos due to their electric field. But as we should be aware that two negatively charged objects experience that force of repulsion. Okay, they repel each other. And again, two positively charged objects also repel each other. So if you try to put two negatively charged objects together, they would want to repel each other, and the same with two positively charged. Whereas opposite charges attract. So a positive charge and a negative charge will attract. Okay, the forces will cause the object to move if they are able to do so. And this is known as an electrostatic force of attraction or repulsion. So electrostatic attraction in this case, and electrostatic repulsion in these two cases. And these forces get weaker the further apart the two things are. So if these objects were here and here, that would be a much weaker force of attraction than this here, because the objects are much closer together. Now, a good example with this is a balloon, and hopefully we all should be aware that if you rub a balloon on your hair, it will eventually stick to your head. Now, what's happening here is as you rub that balloon on your hair, so let's just draw that here, as you rub that balloon from your hair, electrons are transferred from your hair to the balloon. We therefore know that the balloon is going to become negatively charged because it's gaining electrons, so it's going to have a negative static charge. And this hair is going to have a positive static charge because it's lost electrons. And as we've just learnt here, positive and negative attract. So the negatively charged balloon will attract to the positively charged hair, and that's why they stick together when you rub it against your hair. So here is a question for you to have a go at, so pause the video now. Okay, so let's go through these answers then. So every atom contains a nucleus, which is positively charged. The nucleus of the atom is composed of protons and neutrons. The blank in an atom move about in the space surrounding the nucleus. So the electrons in an atom move about the space surrounding the nucleus. An uncharged atom has equal number of protons and electrons. A charged atom is called an ion, and an uncharged atom becomes charged as a result of transferring electrons to or from it. Yeah, remember we just said that static charge is caused from the movement of electrons. If it loses electrons, it becomes a positive static charge, and if it gains electrons, it becomes a negative static charge. And then these two will be electrostatically attracted to each other by a non-contact force because positive and negative attract. So we've now there looked at static electricity. There are plenty of more practice questions for you to have a go at on the website, and as ever, please, if there's anything you didn't understand, please do contact one of our tutors who will happily help.